Hello guys and welcome to it. On this video we'll be again looking at a past paper question that has to do with work, energy and power. So this is our question. It says that a constant force F is applied at an angle of 30 degrees to the horizontal on a crate of mass 6 kg that is initially at rest, as shown in the diagram below. A constant frictional force of 10 newtons acts on the crate as it moves from rest at point A along a horizontal surface to point B. The distance between point A and B is 1,5 meters. The speed of the crate at point B is 2 meters per second. So guys, for us to answer this question, I want you to just make sure that you highlight the most important information. Firstly, we are told that the object is initially at rest, and that means it's at rest when positioned at A, and then it will have an initial velocity of 2 meters per second at B. It will have a final velocity rather of 2 meters per second at point B. And what else do we have? We have the displacement, which is 1,5 meters. We also are given the force of friction there. Then 5.1 says define the term work done by a force. So work done by a force, guys, is defined this way. So guys, this is your definition. It says that the work done by a force is the product of the magnitude of the force F, the magnitude of the displacement delta x, and the angle between the force and displacement theta. Work in simple terms is this formula here, guys. Work done by a force on an object, it is W is equal to F delta x cos theta. On the exam guideline, they define work as this formula, and then they tell you that, F is the magnitude of the force, delta x is the displacement, and theta is the angle between the force and the displacement. So that's another way in which you can define it. You will say that work done by a constant force F is this, where F is the magnitude of the force, delta x is the magnitude of the displacement, and theta is the angle between the force and the displacement. But that's how you define work done by a force. Okay, now guys, we'll look at 5.2. 5.2 says draw a labeled free body diagram showing all the forces acting on the crate as it moves. Guys, when you see that your free body diagram question has 4 marks, that means in this case 3 of the forces that we are going to draw on our free body diagram will be invisible, meaning that it's forces that we can't see, and the other one will be the one that we see. So when we draw our free body diagram, this is how it will be. First of all, by now you know that you draw your dot, and this dot will have arrows facing away from it. So the first force that we are going to start with is this one that we see, the applied force F. So we'll put our F there. Okay, I need to fix my angle. That's what we'll have. That's our F. And now we put the invisible forces. We have the force of gravity. Okay, I'm not drawing straight lines. We'll have the force of gravity or weight. We will have the normal force going upwards. Guys, you will excuse my lines not being straight. Let me try make it look a bit more straight. Here we will have the normal force, and then we will have our force of friction going the other way. So that's how our free body diagram is going to look like, and that's what you guys are expected to have. Okay, yeah, my drawing is not perfect because my lines are not straight, but this is how our free body diagram is going to look like. Then we move on to 5.3. 5.3 says using energy principles only, calculate the magnitude of force F. So if we use energy principles, guys, we use formulas that have to do with this formula. We can use mechanical energy, we can use work done by non-conservative forces, we can use the work energy theorem. Those are mainly the formulas that they want us to use. So I'm gonna do this one firstly with the formula W net is equal to delta EK. So I'm gonna use the work energy theorem to solve this one. And I think what I'm gonna do first, let me see, will this work? Yes, this will work. So what I'm gonna do, guys, is find my work net, which is me substituting the forces that I have that are doing work on the object, right? And then I will equate them to my change in kinetic energy. So the first work that is being done here is being done by the applied force. So I'm gonna write here F delta X cos theta. And what is the other work I'm having here? The other work I'm having is the one that is being done by the force of friction. And if you recall, I was given the force of friction, right? I was told that the force of friction is 10 newtons. So I'm gonna write the work done by friction here by saying F delta X cos theta. All of this will be equal to half mv squared final minus half mv squared initial. Then when I proceed now, I'm going to substitute. F is what I'm looking for, but I do have delta X. Delta X is this displacement from A to B, which is 1,5. And then I have cos theta, my theta in this case, because I'm looking at this work here that is being done by this force. Am I going to put 0 or am I going to put another angle? And the answer is that instead of putting 0 here, guys, we're going to put this 30 degrees. We put 0 if the force applied is actually parallel to what? To the displacement. So in this case, the force applied is not parallel to the displacement, but it's at a 30 degree angle. So here we are going to put 30 degrees instead of 0 degrees due to that fact that our force in this case is at an angle. Then we will have our force of friction here, which is 10. Delta X is still 1,5. Then here we have cos, and our theta will be 180 because this is a force of friction. So work is being done by the force of friction. Thus we have to put 180 there. Then we go to the other side of our formula. We will substitute here our mass of the object where there's m is 6 kg. So our mass is 6 kg. Our Vf, remember Vf is our final velocity, and we found it as this 2 meters per second. So here we are going to put 2, then we'll square it, minus half, in brackets the mass is 6, and here we should put 0 because they told us that this object will start initially at rest, right? So here it should be 0 basically, and then from here, guys, we just use the calculator to get our answer. I'm gonna see this one, I'm gonna leave as it is for now. So what I'm going to have is, or let's just put it as a value, let's just calculate it. So I'm gonna see 1,5 multiplied by cos 30, and the value that I'm getting is, so I'm getting 1,29903. Then I'll write F, and then this one I will see 10 multiplied by 1,5, and I know cos 180 is -1, so it's 10 times 1,5 times -1, and that means I'm going to get -15 is equal to, when I come to the other side, I'm gonna have half multiplied by 6 multiplied by 2, which is squared, and the answer I get is 12. So on this side I have 12, so this 15, this -15 will be taken to the other side. So I'm gonna have 1,299 03F. And here, guys, what you will notice is that I didn't round off my answer to 2 decimal places yet, because it's not the final answer. Okay, that's why I have it like this. So this side we will have 12 plus 15. When I take 15 to this side, it becomes positive. And then from here, guys, I'm gonna divide by the coefficient of f on both sides. So I will divide by 1,29903 on both sides. 1,29903. And therefore, when I divide this, it means I have, if I say 12 plus 15, that means I have 27. But you can put this on the calculator exactly as it is. Okay, so this side, these coefficients cancel, and then on this side 12 plus 15 is 27. So if I say 27 divided by my denominator there of 1,29903, the value that I'm getting for f is 20,78. I hope you tried this one out yourselves, guys, and you got this same answer as me. But yeah, this is our answer for f. Now we are gonna look at 5.4. Okay, guys, now we are looking at 5.4, and 5.4 says we have a 2 kg object which is placed in the case. What effect will this have on the work done by the same force F when the crate is again moved from point A to B? Right, only increases, decreases, or remains the same. So guys, what you will notice here is that on this crate of ours, we have this 6 kg mass, and then what we are doing now, or what we are being told is done, is that a 2 kg mass is being added here. And we are asked, how will this affect the work done by this force F? And for us to answer that question, we have to look at this formula of work. Work is equal to F delta X cos theta, right? So when you check this formula, guys, you'll realize that on this formula, we do not have any mass, right? And what this tells us is that the mass doesn't really affect our work. What affects our work is us changing the applied force or changing the displacement. That's what is going to affect our work. And our theta, of course, because our theta tells us if we are doing negative or positive work. So if we have this formula and we realize that the formula doesn't have mass, it means the mass of the object won't change anything, because the force will remain the same, the displacement will also remain the same, theta will also remain the same. So that means work itself will remain the same. So our answer here will have to be this one. It will be that our work remains the same. Okay, that is what our answer is going to be. Guys, I hope you enjoyed this video and you learned a lot from it. Likewise, if you didn't understand anything, just play back the video and then write everything down. And guys, please do not forget to like and subscribe if you have not. Share the video as well with your friends. I'll see you on the next one. Bye bye.